Alright guys, we're going to talk about relative velocity. Now, what relative velocity is that we're measuring the velocity that is relative to the observer. What we're going to look at, we're going to take, for instance, we're going to say that we're going to make a car, and this is probably the easiest example we can come up with. Here's a car, and then we have another car. Now, they're both moving toward the right, and so they both have a velocity that is moving in a positive direction. Okay, and we're going to say that our first car has a velocity of 15 meters per second. We're going to say that the second car has a velocity of 10 meters per second. Now, what relative velocity is when the person sitting in our orange car is looking at the green car, the relative velocity of the person sitting in the orange car of the green car is going to be 5 meters per second because they're both moving in the same direction. Now, if they were moving in opposite directions, so we're going to say that the yellow car, the orange car, is moving in the opposite direction. Well, what we can see is that the velocity of the green car compared to the observer sitting in the orange car is going to be 25 meters per second because it's relative depending on the observer. Main thing what we look at it when we look at the relative velocity is what you want to do is you want to subtract the velocities. So if we look at this, remember that we have to have this as a vector. So this is going to be negative 10 meters per second. This is going to be positive 15 meters per second. So when we subtract them, we'll go 15 minus negative 10, which when we do that, we see that that turns into a positive. We add those two things, and we get 25 meters per second. With the same thing, when they have both the same signs, they're both moving in the same direction. All we have to do is subtract them again. 15 minus positive 10 now will give us a total of 5 meters per second. So all relative velocity is the velocity dependent on the observer.